In example 2, part A, we need to write a sine and cosine equation given the following information. We know there's a maximum that occurs at pi negative 2 and a minimum at 3 pi negative 6. I've already drawn my axes in. Here's your y-axis and here's your x or theta axis, with a scale of negative 2, negative 4, negative 6 on the y-axis, and pi, 2 pi, 3 pi, and 4 pi on the x-axis. Please pause the video if you need time to write that down. Let's plot these points. The maximum at pi negative 2, and then the minimum at 3 pi negative 6. We also know then that our top line is going to be at the maximum. So here's our top line, and then our bottom line will be here at the minimum. Also, the midline will be directly between the top and the bottom line. Another way to figure out where the midline is going to be would be to take your maximum and your minimum and find the average of the two of those y values. So negative 2 minus 6 is negative 8, divided by 2 is negative 4. This will give us our value of k. K is the vertical shift, and if the midline is at negative 4, then our vertical shift will be down 4. We also can figure out the amplitude from this one. So I'm going to write amplitude here, and we know that from negative 4 to negative 2 would be 2 units, or negative 4 to negative 6 would be 2 units. So the amplitude for this is 2. Another way algebraically to figure this out is to take the distance between these two, which is 4 units, negative 2 to negative 6, and divide by 2, and you wind up with 2. Let me plot some more points for you so we can try to figure out what the period is for this one. So it seems like the graph hits the top line here at pi, and then at 3 pi it hits the bottom line. So we know there's going to be a point right in the middle of those two that hits the midline. Looks like that's 1 tick mark, or exactly pi. So we can go left pi, and that's another point that's going to be on the midline. And then from the bottom line, the minimum, we can move right by pi, and that's going to be another point that hits the midline. If we draw the graph of this then, it's going to look something like this. And again, this is just a rough sketch. The period then is quite apparent. The graph begins here, does one full revolution, or all the y values repeat every 4 pi. If the period is 4 pi, b is 2 pi over the period. Pi's will cancel, simplify 2 over 4 to get 1/2. This will give us almost every piece of information that we need when we write the sine and cosine equation. So let's write the sine equation. If we look at the graph, a normal sine curve would start at the midline. It's going to go up first to the top line. At the second quarter, it's going to come hit the midline again, come back down, and then come back up to the midline where it started. So we don't need to shift this at all, meaning the value of h will be 0, and you won't even see it in the equation. So we can write y is equal to, the value of a is 2. Notice the graph starts up first. We don't have to reflect anything, so we don't need a negative sign. We'll write sine. In the parentheses then, we'll have 1/2, which is our b value. You can either write theta or x here. We don't need an h in this case because we don't have to shift left and right. We do want to shift vertically, though, down 4. So here's your sine equation. If we look at the cosine equation, here we do need to do a shift. So let me draw you a normal cosine equation without a phase shift. It's going to start right here at the top line. At the first quarter, it's going to hit the midline. At the second quarter, hit the bottom line. Third quarter, hit the midline, and then come back up to where it started. So without any phase shift, this is what the cosine curve would look like. So I'll just make a little note of that here. This is our cosine curve. What we want to ask ourselves is, how would we move the blue graph, that's the one without the shift, onto the red one? There's lots of ways to do that, but I think the shortest method is just to move this right by whatever distance this is, and it happens to be right pi. So our phase shift is going to be right by pi. When we write the equation, everything's going to stay the same as the sine. For instance, the amplitude didn't change. Also, b, which is related to the period, didn't change. It repeats in the same distance. And then the vertical shift is the same. The thing that's going to be different is our phase shift. So we'll write, oops, wrote y twice. Y is equal to 2 times the sine of 1/2. And I'm going to use an extra set of parentheses here. Gosh darn it, this is terrible. This should be a cosine. And then you've got a theta. Right by pi is going to be minus pi on the inside. Close up all the parentheses. And then we put our minus 4. So again, comparing and contrasting, this is the sine, this is the cosine equation. The amplitude is the same. We don't need to reflect this because we're moving this point to the right and the graph will start here and keep going. The b is the same. The -4, the vertical shift, is the same. It's just the phase shift that we need to take into account for this cosine curve.